Hello and welcome to the next lecture. In this lecture we will continue talking about the loop functions in R. So let's jump right in it. tapply is a very useful function and it's used to apply a function over subsets of a vector. So the idea is basically imagine you have a vector, usually it's going to be numbers, so a numeric vector, and there are pieces of this vector that you want to calculate a summary statistic over. So you are going to have another variable or another object which identifies which element of this your numeric vector belongs to which group. The idea is that for each group in the numeric vector you are going to calculate a summary statistic like a mean or a standard deviation or whatever. So the basic idea behind tapply is that the first argument is a numeric vector or a vector of some sort. The second argument is another vector of the same length which identifies which group each element of the numeric vector is in. So for example, suppose there are two groups, suppose you have man and woman. For example, in two groups and maybe the first 50 observations are men and the second of 50 observations are women. Then you need to have a factor variable which indicates which observations are men and which are women. And so if you want to take the mean of the numeric factor within men or within women, then you can use tapply to do this. So fun is the function that you want to apply, and so this is going to be the same as before. It's going to be either a function or you can pass in an anonymous function, and then the dot 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 contains the other arguments that may go to this function, and then the simplify argument indicates whether you want to simplify the results, kind of like the sapply simplification. So here's a very simple example. I am simulating a vector of normal random variables and uniform random variables, and there's 10 normals, 10 uniforms, then 10 normals that have a mean of 1. So you can think of this vector as having 3 groups. So then I am going to create another factor variable using the GL function, and this factor variable going to have 3 levels, and each level is going to be repeated 10 times. So when I print out the factor variable here, you can see that there's 10 ones, 10 2s, and there's 10 3s. So the factor variable indicates kind of which group the observation is in. So now I can tapply on x, pass it the factor variable f and the mean function that allows me to take the mean of each group of numbers in x. Now if you don't simplify the result, then what you get back is going to be a list. So tapply applied for the same numeric vector and factor as on the previous slide, and I want to calculate the mean and say simplify equals false. Then I get back a list with 3 elements, and in each element is the mean of that subgroup. I can pass at slightly more complicated summary statistics. So here, instead of calculating the mean which returns one number, I'm going to calculate the range of observations. So this gives me the min and the max of the observations within that subset of the vector x. And so here I'm getting a list where each element is a vector of length 2. So tapply is useful because it splits up a vector into little pieces, and it applies a summary statistics or a function to those little pieces, and then after it applies a function, it kind of brings the pieces back together again. So split is not a loop function, but it's a very handy function that can be used in conjunction with functions like lapply or sapply, and so I just want to mention it here. So split takes a vector, so it's kind of like tapply but without applying the summary statistics. So what it does is it takes a vector or an object x, and it takes a factor variable f, which again identifies levels of a group, and then it splits the object x into the number of groups that are identified in factor f. So for example, if I has 3 levels identifying 3 groups, then the split function will split x into 3 groups, and then once you have got those groups split apart, you can use lapply or sapply to apply a function to those individual groups. So here is a simpler example, similar to what I had before. With tapply example, I have simulated a 10 normal random variables with mean 0, 10 uniforms and 10 normals with mean 1, and has created my factor variable here. And now I am just going to split the vector into 3 parts because the factor variable has 3 levels. So now you can see when I split the x vector, the first I got a list back, and the first element is 10 normals. The second element is 10 uniforms, and the third element which gets a little cut off here is 10 normals again. So that's what the split function does, and now I've got a list. So a split always returns a list back, and so if you want to do something with this list, you can use lapply or sapply. So here, for example, it is common to use the lapply function in conjunction with the split function. So the idea that you split something then lapply function over it. Now in this case, this use of lapply and split is not necessary because you can use the tapply function which will do the same exact thing. It's not any more efficient or any worse to do it this way, but the tapply function is a little bit more compact. But the nice thing about using the split function is that it can be used to split much more complicated types of objects. So for example, here I've got a data frame. I'm loading the datasets package and I'm looking at the air quality data frame from the datasets package. So you can see that this is the first 6 rows of the data of this data frame. I think there's about 100 some rows total in this data frame. And you see there are measurements on ozone, solar radiation, wind and temperature, and then the month and the day within that month. And so one thing I might want to do is calculate, for example, the mean of ozone, solar radiation, wind and temperature within each month. So for in each month there's 30 some observations and I want to calculate the mean within each month. Alright, so how do I do this? Well, what I would like to do is I would like to split the data frame into monthly pieces, and then once I have split data frame into separate months, I can just calculate the means, the column means, using either apply or call means on those other variables. So that's what I have done here. What I have done is I split the air quality data frame, and the factor I'm going to use to split is the month variable. So the month variable, technically speaking, in the data frame is not a factor variable, but it can be converted into a factor variable because it only takes the values 5, 6, 7, 8 and 9. Basically because the measurements are only taken in the kind of warmer months of the year. So here I've split the air quality variable according to the month variable, and then I'm going to apply an anonymous function, and the anonymous function here, what it does is it takes the column mean of just the ozone, solar radiation and wind. So I'm not going to take the mean of temperature here. So I'm just going to take the column means of those 3 variables for each month. So here you can see the results. You can't see them all, but you can see most of them. And lapply is returning a list back where each element of the list is a vector of length 3, which is the mean for ozone, the mean for solar radiation and the mean for the wind within that month. As you can see that for most of the months the ozone value is Na, and that's because when I take the mean of that column there are missing values in that column, and I can't take the mean if there are missing values. So in result I just get a missing value back. So one thing I can do is I can fix this. So before I fix the missing value problem, I can also sapply here, and the idea is that sapply, instead of returning me a list, it will simplify the result because each element of the returned list has a vector of length 3. They are all the same length. So what I will do is put all these numbers into a matrix where the 3 rows and in this case 5 columns. So here you can see the monthly means for each of the 3 variables in a much more compact format. It's in a matrix instead of a list. Of course, I still got NAs for a lot of them because of the missing values in the original data. So one thing I knew is I am going to pass the na.rm argument to call means. That would remove the missing values from each column before it's calculating the mean. And now when I call sapply on the split list, I can get the means of the observed values for each of the 3 variables for each of the 5 months. So split is a very handy function for splitting arbitrary objects according to the levels of the factor and then applying any type of function to those split elements of that list. And so here I split a data frame. You can split the list or other kinds of things too. So the last thing I want to talk about is splitting on more than one level. So in the past couple of examples, I have only had a single factor variable, and I have split whatever the object is with a vector or a data frame according to the levels of that single factor. But you might have more than one factor. For example, you might have a variable that you know its gender, so it has male and female, and you might have another variable that has, for example, the race, and so you might want to look at the combination of the levels within those factors. And so here I've got f1, which is a vector with 2 levels, and so I've simulated a normal random variable with 10 observations. I've got a factor with 2 levels and each repeated 5 times, and then I've got another factor with 5 levels with each repeated 2 times. So there are 2 category, 2 grouping variables here, and I want to look at the combination of the 2. So I can use the interaction function to combine all the levels of the first one with all the levels of the second one. And so because there are 2 levels in the first factor and there are 5 levels in the second factor, and there is the total combination of 10 different levels that you can have when you combine the 2 together. So you see, when I call the interaction function, I get another factor that kind of concatenates the levels of one with the other, and you can see that it prints out that there is a total of 10 levels. Okay, so now I can split my numeric vector x according to the 2 different levels. So now one thing, when I use the split function, I don't have to use the interaction function. I can just pass it a list with the 2 factors, and it will automatically call the interaction function for me and create that 10 level interaction factor. So I can just pass the list of these 2 factors in it, and you can create it returns me a list with the levels of the 10 different kind of interaction factor levels, and then the elements of the numeric factors that are within those 10 levels. Now of course, although there are 10 levels between the 2 different factors, that we don't exactly observe every single combination, and so there are some empty levels here, and you can see that some of these levels have nothing in them. They have 0 elements, whereas other levels have a number in it. And so one thing you can do, well, first I could take this list and lapply or sapply a function over it if I wanted to, but sometimes it's a little bit handy to not have to keep these empty levels. So the split function has an argument called drop, and if you specify drop equals true, it will drop the empty levels that are created by the splitting, and this can be very handy when you are combining multiple different factors. If you are only using a single factor, then that argument doesn't really do anything because you will just use all the levels. But if you have multiple factors, then typically you are going to have empty levels just because you don't observe every single combination of the 2 factors. So drop equals true will drop those empty levels, and then you can have you will be returned with a list with only the levels that have observations in them. So that's it for today. I hope that you will find this knowledge and loop functions very useful, and if you enjoyed my lectures, then do share them and hit the like button and subscribe our channel so you don't miss on latest lectures. So see you in the next lecture. Ciao.